Okay, so today we'll look at alkanes. Alkanes are very good fossil fuels, and that is their main use. So you might have heard of methane, ethane, propane, butane before, and the methane is actually the gas that we use in the lab. So you can get a mixture of propane and butane for your gases that you might use in your households. So we'll look at drawing them today. Alkanes always contain a carbon single bond, and they're generally saturated molecules. So that means that when we're drawing them, we won't have any double bonds or triple bonds within them. And that's how we can identify them when we see the formula or see the structure drawn out. The general formula is CnH2n plus 2. So if we look at that first one, meth, eth, prop, but, we'll need to know all of these prefixes, and it's just a numbering system. Okay, so 1, 2, 3, 4 are slightly different. You'll need to learn them off. But you'll notice that the next few, pent, hex, hept, they follow the shapes: pentagon, hexagon, heptagon, octagon, nonagon, and decagon. So we'll have to finish them off with ANE, methane, ethane, propane, butane, pentane, etc. So let's look at the formula then. For C1, if we have N as 1, that's going to be C. And if N is 1 in here as well, 2 times 1 is 2. 2 plus 2 is 4. H4. Ethane, well, let's put in N as 2. That means C2. If N is 2 on the H's then as well, 2 times 2 is 4. 4 plus 2 is 6. So you just work your way down. So the next one, C3. 3 times 2 is 6, plus 2 is 8. Okay? So you can work out your general formula and all of the formulas for all of them using that general formula. Now when we're drawing them, you will look at the prefix meth, eth, prop, to draw them. Okay, so we're going to first of all draw our backbone. So let's say if we want to draw pentane, okay, we will look first of all at pent, and also the fact that it's an alkane. So that means they're going to be all single bonds. So we'll draw 5 carbons connected with a single bond. Okay, 1, 2, 3, 4, 5. Now we can saturate it with our hydrogens. Okay, so let's see. 1, 2, 3, 4, 5 carbons, that's fine, and it's saturated with hydrogens. We have single bonds, so that's how you draw pentane. If I was to draw ethane, we'll look for the prefix. What does eth mean? What does this stand for? It stands for 2. And then we'll just draw all around it our hydrogens. Okay, so if you want to pause and try and draw hexane, and then you can play it again to see if you're right. Okay, so hexane, that would mean it's still an alkane, so it's all single bonds, and hex stands for 6. So we draw our 6 carbons in first. That's often called the backbone because it's in the middle, and you can imagine the hydrogens around it are acting like your ribs. So you want to saturate them, and that's hexane. you might sometimes see things drawn without the H's, because it does take a lot of time and effort to actually draw them. So for example, if you saw something like this, that actually represents one of these molecules. So each corner basically represents a carbon. So we'll count them: 1, 2, 3, 4, 5, 6, 7. So that means there's 7 carbons on the backbone, which would lead you to believe that it is heptane. Okay, so if you ever see that in an exam, you'll know that that is just a shorthand of drawing out these molecules. Now we can also have side chains, and these will be called your alkyl groups. Okay, so we can have an alkyl group called methyl, ethyl, propyl, etc. Okay, and they might be connected to your original alkane instead of a H. So instead of one of those side branches being a H, it might be an alkyl group. And so all you have to do is take one of the hydrogens away. So we see over here methane is CH4, so the side group was CH3. The next one will be C2H5. The next one will be C3H7. Okay, so it works your way down like that. If I wanted to then draw, let's say, give an example here. 3 methyl hexane. So you're going to ask to draw that. First of all, you need to look at, okay, it's an alkane, so it's all single bonds. And I need 6 of them all connected together. 6, perfect. So that's the first part done. Now, on the third carbon, so 1, 2, 3, we're going to have a methyl group. So you're just going to put in a side chain, pick your methyl group, CH3, and that's that section done. And with the rest of it, you can just saturate it with your hydrogens again. Okay, so that's it done. You can rub out the 1, 2, 3 once you're done with that numbering system. Okay. Now let's say you were asked to draw a molecule with 2 side chains. So that's what I want to ask to be now. Draw 3, 3 dimethyl hexane. So again, we know that 6 C's connected all together. And we have, count them again, 1, 2, 3 on both sides of the third carbon. We're going to have our methyl group. And then you just saturate the rest with hydrogens as per usual. Okay. Now I'm going to give you this time a drawing, and I want you to try and name it. Okay, so let's look at this one. Okay, so you can see how it takes a long time to draw all your H's in. Now, if you want to just pause and try and name that. So remember, you have to look at the long chain of carbons first, figure out which is the longest, then use that as your backbone. Then you can look at your prefixes, try and figure out what type of alkane it is, and then you have to represent the side groups. So give that a go. Okay. So now let's number them. So the side groups have to take the smallest number possible. Okay, so let's find out our carbons. So we have 1, 2, 3. It could go down that way. So that's 4. So that's quite small backbone. So it's probably not going to be that. 1, 2, 3, 4, 5, 6. Because there's 2 carbons there. Let's see if there's a longer one. 1, 2, 3, 4, 5, 6, 7. So that's our longest carbon chain. So we're going to go with that one. And you do need to check which one is the longest. Don't always go for the middle one, like the obvious like straight chain. It could be a side group as well. So now we should number them so that the side groups get the smallest number possible. So let's call this 1, 2, 3, 4, 5, 6, 7. Now we could number it the opposite way as well, which I'll do now. So if we went this way, 1, 2, 3, 4, 5, the first side group will get the number 3, and the next one will get the number 4. If we went this way, the first side chain will get the number 4, and the next one will get the number 5. So you want to go in the direction in which the side groups get the smallest number possible. Okay, so now it's time to name it. So it's definitely an alkane, so I can write ANE. Next thing is what length was the longest backbone of carbons? 7. So I look at my prefixes, that's going to be a hept. Okay, now I have to look at what are my side groups and where are they. So you can do this to the side if you want. Get rid of this for some space. Okay. Side groups are, we have one methyl group, and it's on the 3rd carbon. So we can go 3-methyl, like that. And then we have another side group that's different, which is an ethyl group, and that's on the 4th carbon. So you have to go by the alphabet, not the numbers, okay? So it's going to be actually 4-ethyl first, then another dash, 3-methyl heptane. Okay, so the E comes before the M. Now, moving on to another one. So I'm going to write one now for you to try and do. Let's see. Try and draw 4-ethyl, 5-propyl octane. Okay, so pause and try and draw that for yourself. Okay, so the first thing we look at is how many C's are there. 1, 2, 3, 4, 5, 6, 7, 8. Now, we have an ethyl group on carbon 4. So let's draw that in. There we go. And on the carbon 5, we have a propyl group. Now, 1, 2, 3. That's carbon 4, that's carbon 5. So that's that done. And then all you have to do is saturate the rest with H's. Okay, so that's easy enough. Now I'm going to draw one again for you to name. The naming is often harder than drawing it because you do have to look at the carbons and see which is the longest chain. Okay, so let me draw one for you. Okay, so try and name that one. So first things first is labeling each carbon from either side. So in this circumstance, the side group here actually gets the same number either way, so it doesn't matter which way you go. So how many C's do we have? We have 5, which means we're going to have a pentane. And then what carbon is it on? It's on the third one. So 3 dash methylpentane. And that's it. Now, if I had another one, I'm just going to take out one of those H's and draw in another methyl group. It's still going to be the same numbering because it doesn't matter from either way that we go. But it's still going to be pentane. And we're going to have 3, 3 dash. And seeing that we've 2 methyl groups, I'm going to write dimethylpentane. So di stands for 2. If it was 3 along, let's say another one here, if we had another CH3 there, it would be trimethyl. Okay, so let's actually just pretend that we're going to have another CH3 there. That actually does change our numbering system. Okay, so now let's take a look at the numbers again. If we go this way, it's going to be 1, 2, and the first side group that we see is on the third carbon. If we go this way, 1, 2, the first side group that we see is on the second carbon. So now we have to go this way. Okay, so going this way, we still have pentane. And we have a methyl group on the second carbon. We have a methyl group on 2 methyl groups on the third carbon. So I have to represent that by putting in 2 3s, dash, and it's now trimethylpentane. Now these prefixes here, tri, di, etc., don't have any effect on the alphabetic order at all. So you just look at the E and the M and the P for propyl, etc. to do up your naming system. So we'll do one last one now that you can try and name. Okay, oh, so there you are. There's your next one. This is the last one that you're going to try and name. Remember to number your carbons so that the side groups get the smallest number possible. And then if you have more than one, it's going to be di or tri. And then you need to have each one in alphabetical order. Okay, numbering first. 1, 2, 3, 4, 5, 6. Or I could go this way. So now let's see which one we're going to go for, the purple or the green. In the purple, the first side group gets 2. And in the green, the first side group gets 3. So we're going to go for the purple numbering. Now I can move on. What's the back chain look like? So 1, 2, 3. Not going to be that one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you see that there's actually 2 with the exact same. And if that happens, then you just go with the obvious straight chain. So we have 6, so it's going to be hexane. Now let's look at the side groups. And I always do it to the side before I put it in so it's clearer. I have a methyl group. And I've actually 2 of them, so I'm going to write di-methyl. And they're both on carbon 2. So if you've a few numbers together, you separate them by commas. And then when you move on, you do a dash. Okay, so that's only commas go in between numbers. Okay, now let's see the next one. I have an ethyl group on carbon 4, 4-ethyl. So which one goes first, the dimethyl or the ethyl when you're writing them out? The ethyl group, so that D doesn't matter at all. So we'll write 4 ethyl dash 2, 2 dash dimethyl hexane. Okay, so actually that little comma that's right there shouldn't be there, only in between your numbers. So 4 ethyl dash 2, 2 dash dimethyl. Now there's actually one more thing that I wanted to show you. If the carbons are connected in almost like a cyclic form, all connected together, and if they're saturated with H's, you look at how many carbons there are. So in this one we have 1, 2, 3, 4, 5, 6 carbons, and we're just going to say that it's called cyclohexane. It's like a circle. And if it was 5 carbons, it'd be called cyclopentane.